Question 5 is all about approximating a binomial distribution by using the normal distribution. The first question just asks us what two conditions we need to approximate the binomial distribution using a normal distribution, and that's simply we need n to be large and we need p to be close to 0.5. In part B, we're going to put this into practice, and we're told that a factory manufactures 3,500 light bulbs every day. It's known that 4% of the light bulbs are faulty. So we have our n as 3,500 and our probability as 0.04. So for binomial, we would have the following distribution. Now I am aware that we could just work this problem out that we're about to do with binomial on our calculators, but because it says using a normal approximation, that's what we have to do. So we're going to estimate the probability that at least 100 faulty light bulbs are produced in one day. Firstly, what we need to do to switch this to normal is we need to find the mean and we need to find our variance. To find the mean, we just use NP. Because remember, with a normal distribution, we need both the mean and the variance. So the mean is just n times p. You get these formulae in the formula book. So that's just 140. And then sigma squared, that is just n times p times 1 minus p. If you wanted standard deviation, of course, you would just square root this. So we do the 140 that we just found, n times p, and we times it by 1 minus p. So we times it by 0.96. When we do that, we get either 672 over 5, or, if you like, we get 11.593 squared. Okay, so that's just square rooting that to get my standard deviation and then squaring that number. So what this means is, for my normal distribution, so I'm going to use a different variable now, we'll call it y when I'm talking about the normal, I've got a mean of 140 and a standard deviation of 11.593, so my variance is 11.593 squared. Okay, that gets me 2 marks what I've done there. So in terms of the binomial distribution, so going back to the original problem, we will estimate the probability that there's at least 100 faulty light bulbs. So this would mean I'm trying to find that the probability that x is greater than or equal to, okay, greater than or equal to 100, okay, at least means we include 100. But I'm not doing it for binomial, which is discrete, I'm doing it for normal, which is continuous. So if I'm working out 100 or more for binomial, for normal, I need to apply my continuity correction. And this is where a lot of people lost the remaining 3 marks. Now, binomial is discrete, so just imagine you've got blocks here of 99, 100 and 101. We're including 100, we're including 101, 102, etc. When I do normal distribution, it is continuous, there's no gaps in the data, so I can't just do it at 100. What I'd have to do is I have to treat the number 100 as ranging between 99.5 and 100.5, okay, the lower and upper limits of 100 if I round to the nearest integer. So instead of working it out as 100 or more, I need to work out, for normal, 99.5 or more. Now the greater than or equal to doesn't matter with normal, remember, because it's continuous. So when I use my calculator, I go menu 7, normal CD, my lower limit is going to be 99.5. And then I put my upper limit of just a really big number. My standard deviation is going to be 11.593, or square root of 62 over 5. And my mean is going to be 140. And I've got to be very careful here. I'm going to put this to 4 significant figures, so 0.9998 when I do that. And that would be my answer So very probable, almost certain there. That would be my answer for part B. So the really important thing there though is your continuity correction. Make sure you do that, okay? If it was, let's say, x is greater than or equal to 125, you'd use 124.5. If it was probability that x is greater than 20, then you would use 20.5 in that example, because the first number you include with binomial would be 21. The lower bound of that is 20.5. So just think carefully, do some sketches if you need to for that continuity correction. The final part is just really a bit of functional maths, really, just a bit of financial maths. So a quality control system destroys every faulty light bulb at the end of the manufacturing process. It costs 53p to manufacture a light bulb, and the factory sells non-faulty light bulbs for £7.50. Find the expected profit made by the factory each day. So your expected number to be faulty, we just take that from part B, is 140. Okay, if we make 3,500 every day, if 4% of them are faulty, we expect 140 to be faulty. So to work out our profit, we take away the number that are faulty, so 3,500 that we produce, take away the 100 that are faulty, times that by 7.5. Okay, you're only going to sell the ones that are non-faulty. We then have to take away, though, the cost of producing them, and remember, we need to, even if they're faulty or non-faulty, you still have to produce them in the first place. The cost is the same. So then we just times that by 0.53. Okay, be very careful here. You've got pounds there, you've got pence there, so just make sure you don't make that mistake. And then just simply work that all out for 23,345. Just make sure that your answer makes sense. About 20 grand sounds reasonable for a profit of about 3,500 of the light bulbs. If you're making millions off of that, that probably sounds a little bit too much. If you're making only a few pounds, that sounds too little. So just do that thing of, does my answer make sense?